All right, welcome back. Today we're doing section 3-4, adding and subtracting radicals. And the first thing that you need to understand is that we can only add radicals that are like each other. And what that means is it has to have the same index and it has to have the same inside value to be combined. So if we take a look at these listing of all these radicals, let's group some of the like radicals together and then we will add them. So are there any other radicals like 3 radical 7x? So look through and we have negative 6 radical 7x. Because the radical part is the same and the index is both square root, we can add those. And we would get 3 and negative 6 is negative 3 radical 7x. So we treat the outside numbers, the 3 and the negative 6, as though they're coefficients of a variable. Let's keep going. Is there any other term here or expression like the square root of 2? 10 square root of 2. So the square root of 2 plus 10 square root of 2 is how many square root of 2? And of course it's 1 in front, so it's 11 square root of 2. Is there any radical expression like negative 5 square root of 3? So we're looking for a matching square root of 3, and I have 3 square root of 3. So negative 5 square root of 3 plus 3 square root of 3 is negative 2 square root of 3. All right. Is there anything like the whole number 3 or the integer 3? I don't see any. So let's keep moving along. 2 radical 7. Do I have any other radical 7 terms? There's one. 2 radical 7 plus radical 7. Remember there's a 1 there. That does not have to be written. Equals 3 radical 7. All right, a few more. Let's see if I have anything left here color-wise. Is there anything like the cubed root of 5? So now our index has changed to a 3, cubed root of 5. The only matching term I see is 4 cubed root of 5. So cubed root, I'm not going to be able to do that. All right. Cubed root of 5 plus 4 cubed root of 5, since there's a 1 here, is 5 cubed root of 5. And our cubed root of 2 was the last one here, and there are none like that cubed root of 2, so nothing adds to that. So again, the radical part and the index must match in order to add them together. The radical part must match. Pretty easy, if you think about it, in order to add or subtract. So can we add the square root of 2 and the square root of 5? Well, that answer is going to be no. Can we add the square root of 12 plus the square root of 3? Now watch out for square root of 12. Because it's the square root of 4 times the square root of 3, I can simplify it. And I have matching radicals. So yes, I would be able to add those after simplifying. problem that says solve. So we're going to find the value for x. I'm going to add the square root of 2 over to get my 3x term alone. And then I'm going to divide by 3, but first I want to take care of the square root of 8. Square root of 8 is square root of 4 square root of 2, which you might already realize is 2 radical 2. So on this side, I have 3x equals 2 radical 2 plus radical 2. So that becomes 3x equals 3 radical 2. There's 3 of them here. And then dividing by 3. We get our answer for x is the square root of 2. All right. Take a look at this word problem. The length of each of the congruent sides of an isosceles triangle. Let's draw an isosceles triangle. The length of each side of those congruent sides is the square root of 500 feet. And the length of the third side is the square root of 45. What is the perimeter of the triangle? So we know for perimeter, we add all sides. So let's write that down. Square root of 500 plus square root of 500 plus square root of 45. Some simplification is needed. Square root of 500. Let's break it down into 100 times 5. And 45 is the square root of 9 times the square root of 5. So this works out quite nicely. 10 square root of 5 plus 10 square root of 5 plus 3 square root of 5 is how many square roots of 5? So just look, 10, 10, and 3 is 23 square root of 5. Okay. Next page. So we have a bunch of examples here. Let's work through each one of them. Looks like we could do that. Number 1, we want to simplify first and then determine if we have like radicals. So we're going to do a little bit about what we did yesterday. If you're not sure what goes into 32, break it down and it might help you. It's 2 times 16. Now you could keep going if you want to do the prime factors, but I see 16 is a perfect square. So I'm going to write x square root of 16 square root of 2x for this part. And here I've got 128. Let's start to break that down and see if we get some nice numbers. It's 2 times 64. Well, 64 is a perfect square, so that will really help me there. So 128 is 64, and I've got times 2, and I've got x cubed, which is x. So you can see I did these in 2 different ways. The one I broke up into a perfect square radical, and then the rest. And on the other side, I just sort of stretched them all out so that I could pull out the perfect squares. Either method is fine, just stick with it. So over here, I'm going to have 4x radical 2x. And let's see what comes out of this radical. The square root of 64 is 8, and we have two x's. So an x will come out, and square root of 2x is left. So do we have like radical terms that we can add? Square root of 2x, square root of 2x, yes we do. Let's add their coefficients. 4x plus 8x is 12x. There's your answer. Okay. Let's do the one below it as well. Because it's a cubed root, remember we need 3 of a kind. So 54 breaks down into 9 times 6. 9 is 3 times 3, and 6 is 3 times 2. Awesome. We have 3 3s. So a 3 comes out, and the cubed root of 2 is left. How about 128? Break it down. 128, we had above 2 times 64. Keep going. The 64 is a perfect square, but it's not a perfect cube. So it looks like we're going to get a bunch of 2's. We're even going to get more 2's, because 4 is 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7. Yeah. 128 is 2 to the 7th power. So, whoops, let me move this up. See how much of this will, I don't want that. See how much of this will come up. There we go. Just moving it out of my way, sort of. Okay. Sort of. 128. I need triples to come out. There's a triple, so 2 comes out. Here's a triple, so another 2 comes out. And this 2 is left inside. So we have 3 cubed root of 2 plus 4 cubed root of 2. We have like terms. Cubed root of 2, cubed root of 2. So altogether we have 7 cubed root of 2. Okay, you might want to try that one again on your own. Make sure you got it. Let's keep working our way down. We'll get to that fraction over on the other side in a moment. Want to do back to square roots. So we have 24. Let's see, 24 is 4 times 6, and there's a perfect square. If you want to keep going, you would see there's 2 2's. So I have a 4 times 6. I have an x, and I have y. 54. So if you think of it first, 9 times 6, you have a perfect square. Let's simplify each part. I've got some perfect squares to pull out. I've got a square root of 4 here, square root of 9 here, and I have a couple y's that I'm going to pull a y out of.
Mrs. Finicky, please contact the main office.
So we have 2 coming out, y coming out, square root of 6x plus 3y square root of 6x. So altogether, 5y, 2y plus 3y, radical 6x. Okie dokie, let's work our way back up. From 6, working our way upwards. Again, pause if you want to try these on your own. Pause, pause, pause. and then turn it back on and fast forward. See if you got it right. I will talk my way through it. Here we have 2 times, and the square root of 8a. 8 breaks down into 4 times 2, and I have an a, minus 2 square root of 2a. Nothing there breaks down. Under my radical, I only have a 4 that will simplify for this square root. So the original 2 is there. The 4 comes out as a 2, and I'm left with radical 2a. There's no change on this side. So we have 4 square root of 2a minus 2 square root of 2a, which equals 2 square root of 2a. All right. Moving up, still just adding, subtracting, like radicals. We just have to simplify them sometimes. All right, let me get rid of this giant factor tree for 128. And we are on number 4. So I see some good stuff that can come out of here. I see some good stuff that can come out of here. Let's work this through. Pause if you'd like to try it on your own. The only 2 like radicals I have are these with the square root of 5. Square root of 2a doesn't fit in with these 2 guys. So we end up here with 5a radical 5 minus 5 radical 2a. Sometimes you just can't combine the radicals, and so you just write them in the polynomial form. Last one. So what do I have here? I've got the square root of 5, which I can't do much with, and I've got a fraction. As we said in another lesson, we are able to write the fraction split up as 2 separate square roots, and then what we do with those is we rationalize those. So I'm going to put this one over 1 so that I see that I have 2 fractions. Square root of 5 over 1 plus the square root of 5 over 5. What do you need when you're adding or subtracting fractions? If you said an LCD, you made me happy. So a 5 and a 5, so we get a common denominator. And that takes us to 5 radical 5 plus radical 5 all over 5. And my numerators added together with this invisible 1 is 6 radical 5 over 5, and we are done. Nothing reduces here. Nothing. We're done. Now there's some great problems in the book that you're going to be doing in class tomorrow. I think you'll be in good shape, and we'll stop here. Have a good night.